Hello and welcome to our webinar, Building a Low Latency and High Efficiency Data Warehouse. Before anything else, let me set some context. Today's data-intensive applications require instant analytics at scale, both for internal operations and external customer-facing use cases. Yet, existing solutions force organizations into compromises. Let's look into a traditional data warehouse. It comes with amazing benefits, but needs more speed to support interactive query experiences. While query accelerators or the OLAP engines that does provide real-time analytics fall short of the SQL capabilities and their elasticity. The split approach drives up complexity and cost, leaving data engineers and organizations stuck managing multiple systems that can't deliver millisecond query responses and the full SQL functionality. Moreover, data freshness is often compromised as data must be frequently moved from the cloud data warehouse to the accelerator, creating delays and inconsistencies that hinder instant analytics and decision making. Well, we're here to solve the problem, and we are here to talk about some of the insights that will help us drive and build a low latency and high efficiency data warehouse for data intensive applications. And for that to happen, we need industry experts and subject matter experts who can actually take you through this journey. So let me introduce you to our speakers today. Our first speaker is VP of Product, Firebolt, Igor Stanko. Our wonderful guest and esteemed customer from IQVIA, Jeremy Stroud. He's the Director of IT Architecture, who's going to talk about how Firebolt has helped IQVIA today in their journey and with the impact and outcomes. And then we also have Connor, who's a solution architect at Firebolt. What are we going to cover today in this session, right? So let's look into the agenda. As part of the agenda, we'll be talking about the Firebolt history. Second, we'll take you through the pain points and the trends in the current scenario and the evolution of business within the data and the data warehouse space. We have a big product announcement to make, and we're all excited about it. I hope you also feel the same when you hear about what we have on offer for you. Third, the core product capabilities will be shown in an exciting and excellent real demo, which will blow your minds. Last but not the least, we will hear from IQVIA about their success story with Firebolt. Without further ado, I'll just hand it over to Igor. Igor, take it away.
Thank you, TJ. I wanted to extend warm welcome to you all, and thanks for joining us today. I would like to start by providing a bit of background on Firebolt as a company. We as a company were founded in 2019 by our co-founders Eldad and Sar, who have extensive experience in data space and data-related problems. Since then, we announced the availability of Firebolt Cloud Data Warehouse in 2020. To explain our approach to building that first product, we published a VLDB paper called Assembling a Query Engine from Spare Parts, where we explained how we composed a new query engine by using some of the existing components such as ClickHouse and a few other technologies. In December of 2020, we had our first production customer, leading to the first 1 petabyte scale customer in March of 2021. Since then, we have grown our company by expanding our development centers in both Munich and Kirkland. The reason to open new development centers in these new locations was really to try to be close to where database and analytics experts can be found. Since then, we employed and built a team of industry-known experts to allow us to continuously innovate and deliver best-in-class database experiences. Since we introduced our initial product offering, we've seen successes in many different industries, ranging from edtech, martech, healthcare, and others. We've also seen customers with a range of data scaling needs adopting our technology, ranging from small to very large data sizes, terabyte to petabyte scale customers. Firebolt is all about low latency and high efficiency. We've been able to demonstrate significant price performance and efficiency improvements to the users of our technology. I wanted to use this opportunity to thank all of our existing customers for choosing us and for being the platform of choice for their scenarios and needs. We use data at Firebolt for many things, from product investments to various decision-making processes. To explore the benefits and experiences that our existing customers enjoy while using our technology, we investigated the medium query latency across all Firebolt customers in production spread over the last 2 weeks. As you can see from the graph, There is some variance during the day, but overall, that latency does not cross 150 milliseconds. At Firebolt, we have a goal to deliver experiences that are faster than the blink of an eye, and Graph shows that we've been able to deliver on that goal. I wanted to do a bit of reflection around what we've been seeing in the market through various engagements with our prospects and various customers. First, we've all witnessed the fact that data has been growing exponentially over the years. Old gigabyte is the new terabyte. Old terabyte is the new petabyte. With the rise of new data sources and devices, there is an ever-growing collection of new data that needs to be analyzed and understood. A need for solution that scales as the businesses scale is a paramount need. In parallel, we've seen that more and more companies are making a shift from using the data to understand and improve internal business operations to using the data to offer differentiated data services to their own customers. With growing competitiveness in the market, more and more companies are trying to differentiate themselves by leveraging data as a core asset for such differentiation. This also means that applications that companies build are evolving. From the need perspective, the ability to handle data scalability issues is paramount. New or existing data applications are being built to support newly created data services. As access to the data is being externalized, getting responses in seconds, even 3 to 5 seconds, is no longer acceptable. External visitors are not tolerating slow responses, and millisecond query responses are becoming a very strong requirement. Given cloud deployment and adoption, our customers and prospects continue to demand compute elasticity and access to the compute resources on demand and as needed. Lastly, we witnessed that companies do not have unlimited budgets. Everyone is trying to achieve more with less, leading to efficiency as one of the core requirements for any solution being evaluated and used. To handle these needs, organizations today need to accept compromises. To support their internal analytical needs, organizations are relying on mature cloud data warehousing solutions. For external data applications, various solutions such as ClickHouse, Druid, and other caching layers are being used. In Firebolt, we refer to those technologies as query accelerators. Cloud data warehouses offer maturity and there is proven capability such as robust SQL support, ACID compliance, complex querying, as well as compute elasticity. However, existing cloud data warehouses cannot deliver milliseconds responses and high concurrency needs that modern applications require. On the other hand, while query accelerators offer low latency responses, they do lack support for things such as standard SQL, do not support complex SQL query patterns, they're not ACID compliant, and they do lack compute elasticity. Having both technology stacks in architecture comes with its own challenges. Each stack requires different yet unique skill set. Furthermore, the overall solution comes with increased complexity as the two different systems need to be maintained, leading to high total cost of ownership. When we look back into our original offering, while we had successes with our prospects and existing customers, we also identified some gaps that require deeper attention. With that, today we are happy to announce general availability of our new Firebolt Cloud Data Warehouse product. This product is immediately available in 3 different regions: US East 2, US West 2, as well as EU Central 1 regions. We plan to expand our regional presence over time as we move forward. This new product has been built ground up to deliver low latency analytics that data-intensive applications require. It blends low latency and millisecond query experiences under high concurrency. Combined with rich set of capabilities such as robust SQL support, ACID properties, elasticity, and mixed workload support, this leads to quite unique capabilities from our side. While building this new product, there are 4 core pillars that we were focused on to deliver. The first one is really around delivering on efficiency promises and industry lowest price performance characteristics while enjoying that millisecond query responses. Data-intensive applications drive high and potentially unpredictable query concurrencies that is driven by different usage patterns generated by application users. To ensure we satisfy this requirement, we fine-tuned our solution to enable concurrency at scale. As such, Firebolt can scale to support more than 2,000 queries per second while maintaining performance SLAs. Firebolt also comes with three-way decoupling between compute, storage, and metadata. With this, we enable multidimensional elasticity to ensure our users can fine-tune their compute spend and right-size provision compute to their workload needs and requirements. And finally, all Firebolt functionality from the infrastructure to the queries is backed by a SQL dialect that is Postgres compliant. This is done to ensure that you as a data engineer can enjoy your existing SQL skills while delivering low latency queries. To deliver on these requirements, we had to make significant improvements to our platform. Our new architecture comes with flexible infrastructure through decoupled storage, compute, and metadata layers. On top of that, Firebolt provides a set of data services that can be employed depending on the workload needs. And lastly, Firebolt provides a rich set of APIs and SDKs to satisfy various application needs. While implementing this new architecture, we had to look deeply into various components that our original offering provided. We had to make some tough choices and completely rebuild some of the components from scratch. The perfect example of this is our original reliance on ClickHouse as a backend runtime that is now completely removed with improved and more scalable Firebolt runtime, including our new distributed query engine. This has been a significant effort from investment perspective for us as a company. Just as a few data points in that regards, we as a company invested over 11,000 engineering man hours in the last 2 years to make these changes. This translated also into overall 8,000 code merges over such a period. This new product and architecture is completely complete and significant departure from the old architecture and enables really us to deliver improved experiences and improved behaviors for our users. Our prospects and customers typically look to run multiple and heterogeneous workloads on our platform, ranging from data loading and ELT patterns to low latency interactive analytics. With our three-way engine storage and metadata decoupling, the new platform fully supports deploying mixed workloads. This means that new Firebolt engines are fully stateless and any provisioned engine is fully read-write enabled. Furthermore, any engine has complete access to any managed data and databases. Data or schema modifications made through one engine are fully transactional and immediately visible through any engine endpoint, leading to both full ACID compliant transactions as well as strong and global consistency. What this really means for you is that any data or schema change made through one engine is immediately visible through any other engine endpoint without any need for data or metadata synchronization. With new architecture, Firebolt allows deploying different workloads on different engines, leading to full workload isolation and predictable performance characteristics for each workload. Firebolt engines provide lots of flexibility. Each engine comes with full dimensional elasticity built in. Engines support what we call 3 dimensions of scaling: scaling up and down, scaling in and out, as well as scaling for concurrency. In addition, engines support granular scaling mechanisms where capacity can be added in fine-grained fashion and in increments of one node at a time. These capabilities allow Firebolt users to avoid costly scaling operations that are present in other solutions today. On top of that, engine scaling operations are done fully online, leading to impactless experiences for client applications. All of this allows each deployed engine to be right-sized for the workload while delivering optimal price-performance characteristics. We optimized our product for low latency as well as high concurrency scenarios. Scalability and efficiency are really built into the Firebolt engines. Starting from Query Optimizer that is responsible for evaluating and selecting optimal query plans through our new efficient runtime. This new Firebolt runtime now supports beyond the main memory execution memory model, allowing scalable data processing. Firebolt enables milliseconds response times for small as well as large data scales. To deliver performance and efficiency, Firebolt employs various caching mechanisms ranging from SSD-based caches to intermediate and full result in-memory caches. Another key ingredient for efficient querying is data indexing. Firebolt supports primary and aggregating indexes to help deliver efficiency for both selective as well as complex aggregated queries. And lastly, our new multi-stage and distributed query execution engine allows nearly linear scaling as new nodes are being added into the system. Having access to fresh data is one of the key requirements for data applications. With rapid data ingestion speeds, as well as approximately 200 millisecond DML operations, insert, update, and delete operations, we provide diverse utilities for data to be refreshed efficiently. This allows Firebolt to be kept in sync with various changes that may occur or are occurring in different systems of records. As mentioned earlier, elasticity is something that is required and taken for granted today. However, getting insights into actual resource utilization and recognizing situations where and when to release unutilized resources is not something that is easily available in various solutions that are being used today. Firebolt provides rich observability functionality where Firebolt engines can be monitored in real time to determine current CPU as well as memory utilization. In fact, we are going to see some of that and that aspect of the product in action today. With rich observability being present, data engineers can provision engines that are right-sized for the workloads to be run. New nodes can be added to improve performance due to resource bottlenecks or removed for that matter to realize cost savings due to underutilization. Firebolt also comes with a layered security model and various options to allow developers and administrators to properly secure access to the data that Firebolt manages. From identity management and integration with external identity providers for a single sign-on experience, multi-factor authentication, network IP allowed and blocked lists to fine-grained role-based access control that allows users to manage access to various database objects. And finally, to support full development lifecycle and activities, we've also introduced the notion of Firebolt Workspace. Firebolt Workspace is a development environment to support collaboration among different personas in the development lifecycle while focusing on specific needs of each persona, from developers to the administrators. As we went about building our new product, we explored ways how to actually validate it. What we decided to do is to analyze our existing customers and various engagements with prospects and try to really extract some common patterns for queries that are being used. These patterns range from queries that were ran over a single or multiple tables, aggregated queries with different aggregation functions, various degrees of joins, up to perhaps 50-way joins in certain cases, and so on. The result is that we created what we called new Firebolt performance. We named this Firebolt performance benchmark. We named it FireNewt, that is focused on data-intensive application scenarios and use cases. More specifically, FireNewt contains multiple workloads ranging from interactive analytical queries all the way to ingestion scenarios. The first graph to the left demonstrates execution times for each benchmark query that was executed on our smallest engine instance. And graphs to the right demonstrate scalability of Firebolt and how those performance results look when Firebolt engine is either scaled up to the bigger, where we try to use our bigger node sizes, as well as performance characteristics when engine is scaled out by adding more nodes to the Firebolt engines. As expected, adding more resources into the system leads to improved workload performance characteristics. In addition to the scalability characteristics of the system, we also wanted to validate system behavior under concurrency. With that in mind, we took one of the benchmark queries shown on this slide, and we created 4 million instances of that query with different parameter values. We then used that workload with those 4 million queries against the engine with various cluster configurations, ranging from one cluster all the way to 10 clusters. As it can be seen from the graph, our engine was able to scale to over 4,000 queries per second throughput under 10 clusters configuration. We don't have time to cover all of these results today in details. We published all of the benchmark artifacts in the publicly available S3 buckets that everyone can access it. Also, we published 3 blogs that explain our results in great detail. I would encourage you all to follow our resources link that will be shown at the end of this webinar and learn more about far-renewed benchmark, as well as the performance characteristics that we demonstrated when running it. With this, I would like to turn it over to Connor, who will do a short demo of Firebolt technology. Connor, please take it away.
Thanks, Igor. I'm really excited to show everyone the power of our new product. And there's no better way to see how Firebolt's low latency, high concurrency data warehouse works than by looking at one of our petabyte scale customer use cases. This customer, SimilarWeb, uses Firebolt to power their search analytics application. SimilarWeb's users regularly send hundreds of queries per second to Firebolt and see average response times in the tens of milliseconds. One of the most complex components of SimilarWeb's application is this page: search analysis and keyword research. From this page, users can search for any phrase that might be searched on Google or any website of interest. I'm going to search for a website, orangetheory.com. You can see that SimilarWeb immediately returns data about all the keywords that are sending traffic to this web page from Google search. This page is super flexible. Users can apply a lot of different filters. For example, I'll go in and toggle a filter for month. You could toggle filters for where the traffic is coming from, if it's desktop or mobile web, even switch between whether that traffic is organic or paid. Notice that as I was clicking through all of these filters, SimilarWeb's application remained exceptionally responsive. I was still getting my data down here updated in sub-seconds. The reason that that's possible is because this entire page, all of the keywords, all of the data, is powered by Firebolt. So behind the scenes, this is the query that's being sent to Firebolt whenever a user interacts with the Firebolt application. Or sorry, the SimilarWeb application. As you can see, this is a complex query with multiple CTEs, multiple filters, multiple aggregations, joins, even some operations where we're interacting with array type data. You saw me submit this query a couple of times through the SimilarWeb application, and again, despite the complexity, this was returning extremely quickly. So now imagine that SimilarWeb's application needs constant refreshing. This happens pretty frequently when a user continually reloads the page. Maybe they're expecting the Google search results to change, or they're getting new data loaded into the application in near real time. We can simulate this type of interaction through our demo data app. Here's a quick orientation to the demo data app. So you can see that this dashboard is displaying charts that we've built on top of Firebolt's native observability views. So there's 3 charts that you can see here. Each of them reflect different information about how the engine resources are being utilized. So we've got CPU usage, memory usage, and disk usage. At the top of the screen, you can see the size of the table that we are querying. So this one is about 16 billion rows, 5.4 terabytes uncompressed. And then at the very top, you can see the specification for the engine that we're using. So for this first scenario, we're going to be submitting our queries through an engine with one medium-sized node. So let's return to the SimilarWeb simulation. For this scenario, we're going to send that SimilarWeb query repeatedly to Firebolt through the demo data app. So I'm going to hit run query. And what we're doing now is just pounding the Firebolt application with this query. So as soon as it completes, the next query is sent in succession. And you can see by looking at this latency box, this is flickering roughly between 30 and 35 milliseconds latency. So these queries, despite executing after one another, are still extremely quick. It's worth noting that this is not using any caching whatsoever. So this is just straight up Firebolt speed. So let's look at one more scenario experienced by SimilarWeb. So if you think of their application, or really any data application, there's frequently times of peak load. So hundreds of users simultaneously interacting with the application, generating thousands of queries that are all getting pushed down to your backend database. So on this next page of our demo data app, we're actually simulating that high concurrency scenario. So at the bottom here, you can see that I've configured a concurrency of 1,000. So what that means is that we are always running 1,000 queries at the same time. This is all getting sent through to a slightly differently spec'd engine. This particular engine is a medium engine with 3 nodes and 10 clusters. Now, despite this extremely high level of concurrency, we're retaining very fast sub-second response times. So the latency, again, that query execution time, is between 80 and 90 milliseconds. The throughput is 1,000 queries per second. So this is huge, especially since, again, this is a 16 billion row table, 5 terabytes uncompressed. I can actually jump back into the product and show you what this looks like. Again, a little bit of a, we aren't faking this concurrency. So I'm going to query our engine running queries table, again, on that concurrency engine that we are executing this on. And you can see here that there are literally hundreds or thousands of these queries that are currently being executed on this engine. So finally, data-intensive applications like SimilarWeb's require access to fresh data. But if you're thinking about your data app, you don't want to compromise data freshness with a performance penalty. So users who are interacting with your app still expect you to deliver on performance SLAs. They still want that sub-second response time, and they also want your data to be continually refreshed and updated. And so Firebolt gives customers like SimilarWeb the ability to retain your application performance levels while new data is being ingested. So we can see that on this next tab. So this is our data refresh demo. So again, you'll see we're operating on the same table we've been using this entire demo. The table 5 terabytes uncompressed, 16 billion, 474 million rows and change. Pay attention and try to remember this number right here, because this is going to change over the next few seconds. Again, the engine specification here is different as well. So we're running a small engine with 4 nodes and 1 cluster. So I'm going to start a batch ingestion right now. And as this kicks off, you'll see the rows per second and inserted rows begin to increment. So this is showing that we're now processing data at a rate of approximately 1 million rows per second. You'll see that our total number of rows is still that 16,474,000,000 number. And that's because everything in Firebolt is transactional. So the total row count won't increment until the entire file has been successfully processed and that transaction has been committed. Transactions in Firebolt guarantee ACID properties, so this ensures that your data remains accurate and free of write anomalies. So the cool thing is, if I jump back into this concurrency run, you can see that despite the ongoing ingestion that I kicked off, we're still seeing approximately 80 millisecond latency and almost 1,000 query per second throughput. This is exactly the same as we saw before. There's no degradation. And what you might have just noticed is that the total number of rows actually incremented while I was talking. So it went from that 16,400,000,000 and something number, added 50 million records, and is now at 16,524,000. So you saw in real time, live, that ingestion of 50 million records happen while we still retained high throughput. So how's Firebolt able to retain this performance in the concurrency run while we were running that massive workload on ingestion? We can do this through full workload isolation. So again, jumping back into the app, you can see that that concurrency run is still going on. This is happening on our concurrency engine. If I look at the ingestion engine, and again, query our engine running queries table, you can see, again, we are ingesting data, but that's on a different engine. These two engines have different specifications. Concurrency is that medium 3-node 10 cluster. Ingestion is small 4-node 1 cluster. But those two engines are supporting different workload requirements and simultaneously operating on the same data. You can also monitor the engine metrics directly in the Firebolt application. So you can see here engine monitoring on our ingestion engine. This lets you understand if your workload is fully utilizing all of the available resources, and then you can right-size the engine based on statistics, really tune and dial in your price performance characteristics. The best thing about all of this, our workload isolation, is that all of these engines operating on the same database, in this case, our keyword analysis database, see a single version of truth due to strong consistency. So these three key pieces of Firebolt's functionality, extremely fast query response times, exceptional performance under high concurrency, and best of all, mixed workload support with workload isolation, enable customers like SimilarWeb to power complex data applications directly from their cloud data warehouse. Thanks.
Thank you, Connor. That was amazing. Before we move on, wanted to maybe add a few comments after this great demo. As I mentioned earlier, Firebolt implements layers of various caching mechanisms to deliver on performances that we've just seen, ranging from SSD-based to in-memory-based caches, including result-set caching. In her demo, Connor mentioned that we did not use any caching mechanisms whatsoever. What she meant was really that we disabled result-set caching during the demo so that real computation had to be done when queries were executed, rather than just retrieving pre-computed results. Another thing worth mentioning is the demo we showed did not use just a single query, but rather contained 400 to 500 instances of that SimilarWeb query that Connor showed us during the demo. We use different parameter values to define those unique query instances, and then we ran those queries against the engine endpoints that were present. Before we switch over to IQVIA, I wanted to summarize things that we've seen in the demo. First, Firebolt delivering super fast milliseconds response times. Second, Firebolt delivering high throughput while maintaining milliseconds responses under high concurrency. Our flexible infrastructure delivering multiple things. Mixed workload support with workload isolation to deliver performance SLAs. ACID transactions and the fact that every Firebolt engine is fully read-write capable with immediate visibility into any data or schema changes. In other words, there is no data or metadata synchronization that is happening across different engines. There is a single copy of data and single copy of metadata with full transactional guarantees and global consistency. And last but not least, simple to use SQL first service with native observability to understand resource utilization to optimize that price performance workload characteristics, including Firebolt Workspace to support full development lifecycle. Now, I would like to introduce Jeremy from IQVIA. Jeremy is going to show us how IQVIA uses features that we just demonstrated today in their production environment. Jeremy, please take it over.
Thanks a lot, Igor. Thanks a lot for the overview of the great new features that you're bringing out, and obviously for inviting IQVIA today to share an overview about our partnership with Firebolt. So my name's Jeremy Stroud. So I lead our architecture within some of our commercial products in IQVIA. I've been working with Igor for the last few years, Igor and team, to ensure that Firebolt becomes an important part of our tech stack and supports our scalability and future client needs. We also have a previous webinar, which feels like yesterday, Igor, we did to cover some of the capabilities within our data application architecture and why we feel it's important to have a technology like Firebolt supporting that. So please feel free to take a look. It's got some interesting points that we'll probably build on within this session as well. So first of all, I wanted to give for those that are not familiar, an overview about IQVIA as a whole. And I think this slide sums it up pretty nicely. So at the heart of our organization is an incredible volume of data, which is unparalleled across healthcare and pharmaceuticals. And obviously our focus is the enrichment and cleansing and transformation of that to ensure that we can deliver and maximize the delivery of insights for our clients across healthcare. And that vision and generation of insights supports our goal of smarter healthcare, whether that's speeding up drug development, ensuring the quality and safety of products within healthcare. It could be improving the commercial effectiveness or the support of patient journeys and treatments, or just generally improving access to healthcare for a global population. And one of the things we've obviously seen that's touched most industries, not just the analytics, is the rise of generative AI and large language models, and how they can be used within analytics. And I think it's an important point to bring up, because for us, the type of AI assistance deployed within analytics will obviously start to ask questions around data access and governance that goes well past the classic ARD or gold data layer within the medallion architecture, and start to ask questions around, can we get access to maybe the bronze or silver layers, maybe get access to the full data lake, get access to the full data warehouse, right? As a business user, that is. And obviously, we see that many organizations tend to look to control access and gatekeep access to that data. However, with the rise of generative AI and large language models, we feel it will start to question that and start to provide easier access to that data. And of course, questions will arise around the scalability and application of business rules of data security. How do we ensure that the data is calculated correctly? So that's really looking at the future and now really, and many of the products that IQVIA is delivering as part of its data application architecture are starting to integrate those capabilities. So what about IQVIA and Firebolt? Well, for us, and again, pointing back to that previous webinar, take a look at how we focus on data applications. I think it's an incredibly important trend that Igor has highlighted in his previous slides. So for us, data applications are a step past the traditional BI analytics. That is, how can we provide access to a large number of users, a large variety of data, but not just read-only business intelligence and reporting, but how can we integrate key data workflows? How can we provide a rich data set on top of that data? How can we tightly integrate with that data architecture and start to provide more than just read, right? True rewrite capability. That could be through a suite of applications supporting MDM, master data management, data management, all the way up to next best and machine learning. And of course, that need is there and needs to support various teams and a growing user base. But it also needs to be highly personalized. So how can we ensure that our insights from analytics are highly targeted to our user base? And with our data applications there's a need for performance, obviously. So how can we provide and serve these data applications to our users with millisecond responses? And that is a key reason why we partnered with Firebolt, is to ensure that we can get the most out of our data, that we can deliver the insights as fast as possible. And there's two areas really to that, is how quickly can you get the data in, and obviously how quickly can you get the data out. And Firebolt, through our partnership, is providing unrivaled performance on data loads from our data lake, and is also secondly providing unrivaled performance with its capabilities, such as its unique aggregating index and optimizations within its query engine. So for me, this slide is about data. I also wanted to focus on in my next slide around what about the business needs for scalability. And this is obviously a big part of the problem. So can we serve data performantly to one user is very different to can we scale to support hundreds of users, thousands of users across multiple teams, across multiple organizations, across teams which have various types of workloads that needs isolation. So could we be running machine learning workloads, or maybe we're running analytics. Maybe we're providing capabilities for our AI assistant to provide more of a Q&A on top of our data assets, which focuses more on ad hoc data exploration, for example. So with Firebolt's next generation cloud data warehouse, we at IQVIA can provide that elasticity and scalability to support those client needs. And with the capabilities that Igor has gone through as well, we also get that through an easy-to-use SQL API. So regardless of our needs, we can provide that scale quickly and efficiently to our clients. And obviously there's a question of how we react as well. So how quickly can we scale to onboard new workflows, new data applications, or new data assets, and how quickly we can react to change to ensure we minimize business impact and manage costs efficiently. In my last slide, before I hand back to DJ, I wanted to recap the three key pillars of why Firebolt is supporting IQVIA's vision for healthcare. Firstly, on performance, how quickly we can deliver near real-time and personalized insights to our clients. So obviously the personalization drives extremely dynamic queries within Firebolt. So it's very important that we get millisecond response on huge volumes of data that can't be pre-aggregated or cached ahead of time. On the scalability, so how can our architecture scale to manage diverse data assets, ever-growing data volumes within the lake, and of course, data interactivity through various data applications. And finally, on the governance side, how can we provide capabilities that support the business and unlock data access for large global teams whilst keeping that data security and governance at the front of our minds? So thanks a lot. Let me hand back to TJ, and please feel free to post any questions that you may have. Thank you.
Thank you so much, Jeremy, for taking us through this journey and the impact and outcomes that you have achieved with Firebolt. To our audience who are watching us, the very good next step from here would be to go try the product. And we are giving you $200 in credit so that you can get started with Firebolt and start building your data-intensive applications on Firebolt to achieve low latency and high efficiency. For that, you can go to go.firebolt.io/sign up. Also, as you may need some help to build your first query in just your first data set, we have a phenomenal documentation that can help you in this journey. Get started with Firebolt using our documentation. For that, you can go to docs.firebolt.io/godocs. And if you have questions across different product areas, you can always go to firebolt.io/FAQs. We can find different type of questions that our customers have been asking, that we have learned in this journey working with prospects and customers, and also a lot of different questions that we have learned ourselves from an engineering and product perspective. Those all questions, probably a lot of that answers you will find there in the FAQs. Last but not the least, we do have a few resources for you so that you can get a lot of the validations that we talked about today. The launches happened of the product, so you can go and look a little bit more details about what does the product really covers end to end, and different feature set, the value proposition, and what is that it brings to your organization. For that, you can go to our launch blog. We also do have an excellent blog from our CTO, Moshe, who was able to kind of take us through this whole journey of how we built Firebolt and why we built it. So you can definitely look into the link over here and go ahead and read more about it. We also, as kind of Igor mentioned, you saw in the demo what Connor showed you, a ton of the benchmarks are something which we aren't trying to hide. We really want you to go and see how we achieved all of it. So we are releasing all the benchmark blocks today. And for that, we have 3 different benchmarks, one on performance for low latency and high concurrency. We do have another benchmark block for ingestion benchmark. We have another one for DML benchmark. And for any detailed, insightful, engineering-centric information, you can always go to our white papers at firebolt.io/white papers. On that note, my name is TJ. I head product marketing here, and I really thank you for watching us. Hope you liked what we had to share with you today as part of the content, as part of the webinar, and I hope you will join us soon again. On that note, have a good one. Take care.